And if you look at the assignments next week, there's like a lot of like no classes.
Oh, because we have extended next week.
Got extended.
Because we
Are
have
Some of
we
you,
done with
some of you might have AP exams too.
Mr. Short, are we almost done with like learning?
Yeah, this is the last chapter.
Oh, wait.
we have May Day on Tuesday.
Yeah, but that doesn't mean we can stop learning.
We're just gonna review.
I'll tell you what we're doing.
If we review, can we have a visit?
Don't worry, I'll tell you what we're gonna do. Okay, what problems are we going over on the homework? Go.
Shit.
What is it?
Need the homework. What was homework?
Design.
What problems are we doing on the homework? What does this mean? We didn't do the homework.
No, I'm trying to find it.
Okay, because on the test, I don't know when the test is, if you look at your assignment sheet, but there's a lot of graphing on this test. You gotta get this graphing down. I'll worry about it later, Mr. Bart.
No, the assignment sheet said we had to do like 3 cosine theta.
Yeah, you have to add those in. Those are the circles that we learned, yeah?
Oh, okay.
No questions then. I find that hard to believe. So if I give you a quiz on this, then you guys should be able to nail it.
51.
51. What, shall I just do them all then?
47.
Give me the assignment at least.
What was it?
37 to 51.
What is it? 37 to
51 on.
plus the other ones, right?
Yeah.
R equals,
3 cosine.
R equals, R equal, and R equal. Okay, you know what? Why don't I just do them all super quickly and get it on video then, because some of you look out of it. It's Friday. Oh, can I just zone out?
So we're fried. Bless you.
Okay, you know what? I'm just gonna do them real fast. 37. So for real, R equals 2 plus 2 cosine theta. Hey, that's a limousin. Maybe we should do these first. No, it don't matter. Hey, that's a limousin. Now, how did I tell you to do the limousin? You plot the quadrantal angles. So if you plug in 0, you get 4. You plug in 90 degrees, you get 2. You plug in 180 degrees, you get 0. You plug in 270, you get 2. Connect the dots. Blowing to the west, 39. There she blows! Okay, look, that number and that number are the same. It'll be another cardioid again. But like I said, you don't need to know that. Just plot. Okay, plug in 0, 3. Plug in 90 degrees, 0. Plug in 180 degrees, 3. Plug in 270, it's gonna be 6. 1, 2, 3, 4, 5, 6. And 1, 2, 3, 6. And then there you go. 41. R equal 2 plus sine theta. See how this number bigger than that number? It's going to be a monopole. So plot the quadrantal angles. Plug in 0, 2, 90 degrees, 3, 180, 2, 270, 1. So here we go. Monopole. 43. R equal 4 minus 2 cosine theta. That number bigger than that number, monopole. Plug in 0, 2. Plug in 90 degrees, 4. Plug in 180 degrees, 6. 1, 2, 3, 4, 5, 6. Plug in 270 degrees, 4. And then, are you guys getting these? It's pretty easy. Just plot the angles like I told you. Okay, 45. I can't even read it. R equal 1 plus 2 sine theta. That number is smaller than that number, so this is the hemorrhoid, right? It's going to have the cardioid with the hemorrhoid inside. Okay, so plot 0, 1, 90 degrees, 3, 180, 1, 270 degrees, -1. See how the point is up there? See, so you got the cardioid part like this, but then you got the loop inside it, the hemorrhoid, whatever you want to call it. Okay, 47. Where's 47? R equal 2 minus 3 cosine theta. Okay, same thing. That number smaller than that number. You're going to have the inner loop. So, plot 0, negative 1, 90 degrees, 2, 180 degrees, 5, 2, 3, 4, 5, 270 degrees, 2. Okay, see how this point is inside the other three? See, that's why you have the cardioid like this, and then you got the loop inside it. Like that. Look how fast this is. 49. Okay, these are the Rose curves. 49. R equals, gosh, I can't even read the quote. 3 cosine 2 theta. Okay, how many petals are there going to be?
3.
No!
How many 4?
That number tells you how many petals. If it's even, you have twice as many petals. You're going to have 4 petals. This number tells you the length of each petal. Each petal is going to be 3 units long. So this one, like I told you, this one you might want to use your polar graph paper. Okay? So if this is a cosine 1, what do I set that equal to? If it's a cosine 1. Okay, I'll give you, it's either 0 or 90 degrees. 0, because cosine of 0 is 1. Divide both sides by 2, you get 0. So the tip of the first petal is going to be at 0. And they're all going to be equally spaced apart. So they're going to be all 90 degrees apart. So it looks like this. Actually though, when you graph it on your calculator, that's not how it goes. When you graph it on your calculator, it actually goes like this. Okay, but right now you don't really need to know that. You just gotta draw the graph. But when you take calculus, you gotta know that. Because in calculus, you know what we do? We compute the area and the perimeter of this thing. Sounds interesting, Mr. Park. 51. R equal 4 sine, gosh, I can't even read that number. 5 theta. Okay, how many petals? Look, that number tells you how many petals. How many? 5. If it's odd, that's how many you have. Each petal will be 4 units long. Okay, so. Okay, now when you have a sine Rose curve, you have to set this thing equal to 0 or 90? 90 degrees. Divide by 5, theta is 18 degrees. So 18 degrees, you're going to have the first petal. And then you're going to have 5 petals all equally spaced apart. So 360 divided by 5 is 72. So every 72 degrees, you're going to get the tip of a petal. So 18 degrees, add 72 to that, you get 90. Add another 72, what is that, 162? And then add another 72, what is it, 234? Will be about there. And then add another 72, will be there. And remember, do not overlap. Oh, I don't want that. Do not overlap the petals. It's pretty good. Thank you. Okay, and then the 4 additional graphs you're supposed to draw. These are the circles. Okay, these are all circles. Okay? Okay, so the first one. You know what? Maybe we should draw all of them on the, no, let's not be lazy. 3 cosine theta. Remember, the number in the front tells you the diameter of the circle. They all pass through the origin. And remember, the cosine ones are here and here. The sine ones are here and here. So the first one, you just go like this. Okay, the second one. That's the diameter. This is a sine one, positive, so it's going to be up here. The third one, cosine one, but it's negative, so it's going to be on this side. 1, 2, 3, 4. And then finally, the last one. Okay, what is that? Sine one, negative, so it's going to be down here. 1, 2, 3, 4, 5. So Ooh, oh shoots. Ah, that's ugly, -1. Okay, 99 is a very good score. It looks like the same thing.
We have played something
Of course, if it's too emaciated and sickly, minus. It should be healthy and plump. Yeah. Come on, a circle. You guys know what a circle looks like, right?
Yeah.
I should hope so. All right, I did all the problems for you. You're welcome.
Thank you.
Thanks.
Don't say it after. Okay, but now you guys gotta do this on your own, you know. The practice test is coming up soon, you know. Okay, let's learn what we gotta learn and then, okay, today's lesson is easy. I'll tell you what, I'm not seeing you on Monday. I see you on Tuesday extended. Okay, that lesson is pretty tough now. That's pretty much the last lesson of the whole year right there. Wow.
When's the test?
Well, look at the assignment sheet, whatever it says on there. Okay, I can erase this now. All the quizzes are done. Except the next one. Is this period 1 or 2?
1.
It's only 1, it feels like 2.
Is today graphic or is it?
No, today we're not graphing. We did all the graphing already. Okay, today what we're gonna do, is there like a application of complex numbers? Like this this polar thing? Why are we learning it? Just so teachers have jobs? No! Of course, yes, there is an application for it. And that's in engineering. So if any of you major in engineering, it doesn't matter what kind, you're gonna see this again. But especially electrical engineering, because you guys know the difference between alternating current and direct current?
It's the wave.
Direct current is like you have batteries. Alternating current is like when you plug into the wall. To analyze alternating current, we use complex numbers. Okay? And you guys know what complex numbers are? A plus B, I. Remember I
Oh, and then.
from algebra 2A?
Yeah.
Yeah, imaginary number. Okay, we gotta review. Okay, what is this number I? And you know this is on the new SAT, and I think is it on the ACT? I'm not sure, but I know on the new SAT it's there for sure. I is equal to the square root of -1. It's an imaginary number. Okay, and then what was I squared equal to? -1. What is I cubed? -I. And then what is I to the 4?
1.
1, and then it kind of just repeats itself. Remember that? So a complex number is a number that can be written in the form A plus BI. Usually complex numbers we denote with the letter Z. This is called the real part. This is called the imaginary part. Now, when you first learned it in Algebra 2, they just told you, okay, this is a complex number, but they really didn't tell you what it is. A complex number is actually a vector in the complex plane. So for example, if you have the vector 4 plus 3i, we can actually graph that in the complex plane. Now, you guys are just used to the Cartesian plane where you have the x and the y axis.
Isn't there the
The
axis?
complex plane, we have the real and the imaginary axis. But it's the same thing. You just gotta think of it differently, okay? So if this is the real part, and that's the imaginary part, basically it's like plotting the point 4, 3. That's basically what you're doing. So you go 4 to the right, you go 3 up, and you plot that point. Okay? Now, a complex number is actually a vector. Now, some of you don't have experience with vectors, but for now, all you just have to know is a vector is an arrow, okay? An arrow that goes from the origin to the point. Right there. This complex number is that's what it is. It's a vector right there. It's a vector that goes from the origin to the point 4, 3 in the complex plane, not the Cartesian plane.
Does this arrow go through the point?
No,
Just
that's it.
Okay.
No, it starts at the origin and it ends at the point. Okay? Okay, so this is just like the introductory thing though. Of course, if you take engineering courses, then you're gonna learn exactly how to use these things. Okay, well you gotta learn the basics. Okay, now, is this the only way to write a complex number though? In the form A plus BI? Well, that's all you know right now. But since we're studying polar coordinates, there is another form. See, this is called standard form. Today we're gonna learn polar form of a complex number. Okay? Now, a complex number can be written in this form. Like I said, this is called standard form. But another way to write it is like this. R kiss theta.
What kid?
What? Now, this kiss thing is actually an abbreviation for cosine theta plus I sine theta. But see, that's a lot to write, so we just write kiss. It's a lot faster. John, you paying attention?
Mhm.
Sure.
Mhm.
So the imaginary is in front of the sign now?
You better put that computer away.
Oh, no, I just saw this.
That's not this.
Sorry, I fell asleep.
I wish I could tune out. Oh, I forgot what I was talking about already.
You're talking about how.
Oh, arc is theta, okay. So, you know what this R represents? So this is exactly like polar coordinates. See, this is X and this is Y, right? In the rectangular coordinate system. What is R and theta? This is R and this is theta. It's exactly the same as the polar coordinate system. That's why we call it polar form. So tonight's homework, all you have to do in tonight's homework is convert from standard to polar and polar to standard. That's all you have to do, okay? So why don't I just do some examples, okay? That'll probably be the easiest for you. Okay, let's say if I want to convert from polar to standard form. Okay, I'm going to erase this. Okay, let me give you polar form. How about 4 kiss 30 degrees? How do we convert that into standard form? Well, remember, KISS is an abbreviation. It's an abbreviation for cosine theta plus I sine theta. That's what KISS stands for. Now, I'm not sure how your book writes it, but then when you go to higher math, that's the way we write it. Your book actually might write the whole thing out like that. It's kind of a pain. That's why we have this abbreviation here. And then now, all you have to know is your trig values. See, look, R cosine theta is X. R sine theta is Y. It's exactly the same thing as what we learned. Okay, what is cosine of 30 degrees? Okay. What is sine of 30 degrees? 1/2, and then we put the I. You always put the I with the sine part. And then all you have to do now is distribute the form. What happens when you distribute the form? 2√3 plus 2I. Bam! That's how you change from polar to standard form. You simply change the KISS to what it actually stands for, and it's easy. Okay, let's do one more. What if you had 3 KISS 270 degrees? Okay, so this is what you do. What does KISS actually stand for? Cosine theta plus I sine theta. See? C is the cosine, I is the I, and S is the sine. It's an abbreviation. Okay, now you just got to know your trig values. What is the cosine of 270 degrees? 0. What is the sine of 270 degrees? -1, and then you put the I on the, you always put the I on the second one, and then all you have to do now is distribute the 3, and so your final answer is 0 minus 3I. We don't write the 0, but if you want to put the 0 there, you can. So to convert from polar to standard, it's very simple. Just change the KISS into what it stands for. Now, what about going the other direction? Standard to polar. Hey, we're almost done. Standard to polar. Okay? Well, what if I give you 2 plus 2I? How do you change this to polar? Well, just like the homework we had several nights ago, well, what did I tell you? What is the fastest way to change from rectangular to polar? What did I tell you? Draw the picture, exactly. So here we go. Except instead of now having an X and a Y axis, you have a real and an imaginary axis. That's the only thing that's different. So if the real part is 2, you go 2 to the right. The imaginary part is 2, so you go 2 up. So you go here. So basically you plot the point 2, 2. That's what you're doing. And then you draw a vector. Now you really don't even have to draw the vector, but it's there. Okay? R is the length of this vector. Well, if this is 2 and that's 2, what is the hypotenuse right there? 2√2. So if I want to change this into polar form, this distance is 2√2, right? Because it's a 45, 45, 90 triangle, right? The hypotenuse is radical 2 times the short length. And then Just look at this picture. What is that angle right there? In fact, I just told you, it's a 45, 45, 90 triangle. It's 45 degrees. Finished. Just draw the picture. Okay, do one last example. Negative 3 root 3 plus 3i. Change this into polar form. So we want to change this into the form r kiss theta. All you have to do is draw the picture. Instead of the x and the y axis, you got real and imaginary. So go 3 root 3 to the left. So 3 root 3 to the left, here, 3 root 3. And then you go 3 up, like that. How far from the origin are you? We did this 2 nights ago. I'll give you a hint. This is a 30, 60, 90 triangle. Look, in a 30 and 60, 90 degree triangle, the hypotenuse is double the short leg, so that's 6. That's r. See, that's how far you are from the origin. Now, if this angle here is 30, what's that angle going over there? 150. Now, when we do this, I don't care whether you do degrees or radians. So you can write 150 degrees. Other people like radians, so then you write 5 pi over 6. I don't care. You can write either. I'll not accept either. Okay, so tonight's homework is easy. This is just like converting rectangular into polar and polar into rectangular. We already did it already. The only difference is instead of having x and y, you now have a and b, right? See, this is the only difference. You convert it into this, and then a plus bi. It's exactly the same. This is that, and that is that. Okay, however, like I told you, when am I seeing you next? I forget the Tuesday. That lesson is pretty tough. All right, we're done. 15 minutes early.